NASA Artemis Program, History, Present and Future. The Artemis program launched by NASA marks a significant milestone in the ongoing exploration of space, particularly focusing on returning humans to the Moon and establishing a sustainable presence there. This ambitious initiative aims not only to enhance scientific discovery but also to build the foundation for future crewed missions to Mars. Historical background of the Artemis program. The Artemis program is named after the Greek goddess of the moon and sister of Apollo, signifying a new era of lunar exploration following the historic Apollo missions of the 1960s and 1970s. The Apollo missions successfully landed humans on the moon, with Apollo 11 being the first in July 1969. After Apollo, human space exploration shifted focus primarily to low Earth orbit missions, including the Space Shuttle program and the International Space Station ISS. In 2017, NASA announced the Artemis program as part of a broader strategy to advance human exploration beyond low Earth orbit. The program aims to land the first woman and the next man on the moon, with a focus on the lunar South Pole, a region rich in resources and scientific interest. Overview of the Artemis missions. The Artemis program comprises several key missions, each designed to build on the success of its predecessors and push the boundaries of human exploration. 1. Artemis I, launched in November 2021. Artemis I was an uncrewed mission that tested NASA's Space Launch System (SLS) rocket and the Orion spacecraft. The mission successfully circled the moon, validating the systems necessary for future crewed flights. 2. Artemis II, scheduled for launch in April 2026. Artemis II will be the first crewed mission of the program. 4 astronauts will embark on a 10-day mission, flying around the moon and testing the Orion spacecraft systems in a deep space environment. This mission is critical for confirming that all systems function correctly with a crew on board. 3. Artemis III, planned for mid-2027. Artemis III will land astronauts on the lunar surface, specifically targeting the lunar South Pole. The mission aims to conduct scientific research and exploration, with astronauts expected to spend approximately a week on the moon. This mission will mark humanity's return to the moon after more than 50 years. 4. Artemis IV and beyond, future missions will involve the establishment of a lunar gateway and further exploration of the moon, culminating in sustained human presence and the eventual preparation for Mars missions. Scientific objectives of the Artemis program. The Artemis program is not just about returning to the moon, it is also focused on scientific discovery. The missions aim to explore the moon's geology, study its resources such as water, ice, and understand its history as a time capsule of the solar system's evolution. The data gathered during these missions will enhance our understanding of planetary processes and contribute to our knowledge about Earth and beyond. International collaboration and commercial partnerships. One of the pivotal aspects of the Artemis program is its emphasis on international cooperation and commercial partnerships. NASA has established the Artemis Accords, a framework for collaboration in space exploration. To date, over 50 countries have signed the accords, committing to principles of peaceful exploration, transparency, and the sharing of benefits derived from space activities. Additionally, partnerships with commercial space companies are integral to the Artemis program. For instance, SpaceX has been selected to provide the Human Landing System (HLS) that will transport astronauts from lunar orbit to the moon's surface. This collaboration reflects NASA's strategy to leverage private sector innovation to achieve its goals. Future aspirations, from the moon to Mars. The ultimate aim of the Artemis program extends beyond the moon. NASA envisions using the moon as a stepping stone for future crewed missions to Mars. The technology, systems, and experience gained from the Artemis missions will inform and prepare astronauts for the challenges of interplanetary travel. Conclusion. The Artemis program represents a bold new chapter in human space exploration, aiming to return humans to the moon and pave the way for future journeys to Mars. By combining scientific discovery, international collaboration, and commercial partnerships, NASA is not only rekindling the spirit of exploration but also inspiring the next generation of explorers. The upcoming Artemis missions hold the promise of expanding our understanding of the Moon and the solar system, ultimately leading humanity further into the cosmos. The NASA Artemis program represents a significant shift in lunar exploration with objectives that extend beyond the Moon. Here are some counterintuitive aspects of the program and its implications for the future. 1. International collaboration versus national pride. While the Artemis program is often framed as a demonstration of American leadership in space, it relies heavily on international cooperation. The Artemis Accords, which have been signed by over 50 countries, highlight a collaborative approach rather than a competitive one. This is counterintuitive to the historical context of space exploration, which was dominated by nationalistic pride during the space race. The expectation that lunar exploration would be a solitary endeavor for the United States has shifted to a more inclusive vision that recognizes the benefits of shared knowledge and resources. 2. Focus on the South Pole. The choice to target the lunar South Pole for Artemis III may seem like a return to a familiar landing site akin to Apollo missions. However, the South Pole is not just another area of interest, it is strategically significant due to the presence of water ice. The ice at the Moon's poles can potentially serve as a resource for future missions, providing not just water for astronauts but also hydrogen and oxygen for fuel. This resource-driven approach to lunar exploration contrasts with earlier missions that primarily focused on surface exploration for scientific knowledge without considering long-term sustainability. 3. Return to the Moon as a stepping stone to Mars. One might assume that the focus on returning to the Moon indicates a long-term commitment to lunar exploration. However, NASA explicitly states that the Moon is a proving ground for technologies and methods that will be essential for future Mars missions. This duality of purpose, using the Moon both as a destination and a training ground, challenges the perception that lunar missions are merely a nostalgic return to past achievements. Instead, they are a strategic preparation for more ambitious interplanetary exploration. For technological development for sustainability, the Artemis program emphasizes developing technologies that support sustainability in space rather than just conquering new frontiers. For instance, the program aims to create a lunar economy through commercial partnerships, which is a shift from the traditional model of government-funded space missions. This approach suggests that future exploration will depend on a sustainable economic model rather than solely on government budgets, leading to a potentially broader and more resilient space exploration ecosystem. 5. Diversity in astronaut selection. The intention to land the first woman, first person of color, and first international partner astronaut on the Moon challenges historical narratives that have often centered on a homogeneous group of astronauts, predominantly white and male. This decision reflects a broader understanding of inclusion and representation in space exploration, which is a significant departure from past missions. The implication is that the future of space exploration will not only be about technological prowess but also about who gets to participate in these historic endeavors. 6. Shifting scientific objectives. The Artemis missions are not solely about human exploration but also about extensive scientific research, particularly in understanding the Moon's geology and potential resources. The focus on field geology, sample collection, and scientific experiments at the lunar South Pole suggests that the program is as much about advancing scientific knowledge as it is about human presence. This dual objective may be surprising to those who view manned missions as primarily exploratory. 7. Role of commercial partnerships. The integration of commercial entities into the Artemis program indicates a fundamental change in how space missions are conducted. The reliance on private companies for launching payloads and developing lunar landers challenges the traditional view of space exploration as a strictly government-led endeavor. This shift could lead to more innovation and efficiency, as private companies often operate with different incentives and methodologies than government agencies. 8. Public engagement and inspiration. The Artemis program is designed not only to achieve technical goals but also to inspire the next generation. This is counterintuitive when considering that previous missions often focused on the technical achievements without as much emphasis on public engagement. The current narrative encourages young people to participate in STEM fields, suggesting that the impact of the program may extend far beyond scientific and technological advancements. In conclusion, the NASA Artemis program embodies a multifaceted approach to lunar exploration that blends collaboration, resource utilization, sustainability, diversity, and public engagement. These counterintuitive elements redefine the narrative around human spaceflight, positioning the Moon as both a destination and a launching pad for future exploration of Mars and beyond. The NASA Artemis Program, which seeks to return humans to the Moon and pave the way for future Mars missions, encompasses various significant elements that are often overlooked. Here are some of these critical aspects along with their implications. 1. Historical context and legacy. While many discussions around the Artemis program focus on its future missions, the historical context of lunar exploration is crucial. The Apollo mission set a precedent for human spaceflight, establishing a legacy of international cooperation and scientific discovery. The Artemis program aims to build on this legacy, not merely replicating past achievements but expanding human presence in space. Understanding this historical continuity is significant because it shapes current public and governmental support for the program and underscores the importance of sustained human exploration beyond Earth. 2. Inclusivity in exploration. The Artemis program emphasizes inclusivity by committing to landing the first woman and the first person of color on the Moon. This aspect is often glossed over in technical discussions but is vital for inspiring a new generation of explorers from diverse backgrounds. It signifies a shift in who gets to participate in space exploration, moving beyond the traditional demographic of white male astronauts. This is significant as it not only reflects societal changes but also broadens the pool of talent and creativity in the field of space exploration. 3. International collaboration. The Artemis Accords, which have been signed by over 50 countries, highlight the program's commitment to international collaboration. Many reports focus on NASA's technology and missions but overlook the geopolitical implications of such partnerships. The Accords lay the groundwork for a cooperative approach to space exploration, promoting peaceful uses of outer space and ensuring that the benefits of exploration are shared globally. This collaborative effort is vital for establishing norms and practices that will govern future space activities, making it a cornerstone of sustainable exploration. 4. Economic and commercial opportunities. The Artemis program has significant implications for the commercial space industry, yet discussions often center around the technical aspects of missions rather than the economic potential. The program is fostering a lunar economy through initiatives like the Commercial Lunar Payload Services (CLPS), which encourages private companies to deliver payloads to the Moon. This commercial aspect is crucial as it could lead to innovations, job creation, and economic growth in the aerospace sector. Ignoring this aspect overlooks how public investment in space can stimulate private sector growth and technological advancements. 5. Environmental and scientific research. The scientific objectives of the Artemis missions, particularly regarding the Moon's resources and environment, are sometimes underestimated. The Moon is viewed as a scientific treasure trove that can provide insights into the solar system's history, including Earth's. The potential for discovering water ice at the lunar poles is particularly significant for future long-term human presence on the Moon and for supporting missions to Mars. This aspect of the program is crucial because it addresses fundamental questions about our planet's past and future, as well as the sustainability of human life beyond Earth. 6. Technological innovations. The Artemis program is not just about sending humans to the Moon, it represents a platform for advancing critical technologies. These innovations range from advanced robotics and autonomous systems to new life support technologies. The development of the Space Launch System (SLS) and Orion spacecraft represents a leap in capabilities for deep space exploration. Recognizing the technological innovations driven by Artemis is important because these advancements will have applications beyond lunar exploration, potentially benefiting other sectors on Earth. 7. Public engagement and education. The Artemis program aims to inspire the Artemis generation through educational initiatives and public engagement. While this is mentioned in various reports, its significance can be understated. By involving students and educators in the mission, NASA aims to spark interest in STEM fields and create a well-informed public that supports space exploration. This focus on education and outreach is essential for cultivating the next generation of scientists, engineers, and explorers, ensuring a sustainable future for space exploration. 8. Long-term vision for Mars exploration. Finally, the Artemis program serves as a stepping stone for Mars missions, yet this long-term vision is often overshadowed by immediate mission goals. The lessons learned from lunar exploration will inform the challenges of Martian exploration, such as habitat construction, resource utilization, and life support systems. Recognizing this connection emphasizes the strategic importance of the Moon as a testing ground for technologies and strategies that will be critical for future human missions to Mars and beyond. In conclusion, while the Artemis program garners attention for its missions and technological advancements, its significance extends far beyond these aspects. Historical context, inclusivity, international collaboration, economic opportunities, scientific research, technological innovations, public engagement, and its long-term vision for Mars all contribute to a comprehensive understanding of why the Artemis program is a pivotal moment in human space exploration. Each of these elements deserves attention as they will collectively shape the future of humanity's presence in space. 1. Historical context and objectives of the Artemis program. The Artemis program marks a significant return to lunar exploration for NASA, emphasizing not only the revival of human presence on the Moon but also the establishment of a sustainable presence. The program aims to build on the legacy of the Apollo missions while expanding the scope of scientific research to include the Moon's resources, particularly water ice, which could be crucial for future deep space missions, including Mars. This historical context highlights a shift from merely exploring the Moon to utilizing it as a stepping stone for further space exploration. 2. Technological innovations and infrastructure development. Central to the Artemis program are advancements in technology and the development of essential infrastructure. Key components include the Space Launch System (SLS) and the Orion spacecraft, which are designed for deep space missions. Additionally, the program plans to establish the Lunar Gateway, a space station in lunar orbit that will support long-term missions and serve as a hub for crewed lunar landings. The integration of new technologies such as advanced spacesuits and human landing systems underscores NASA's commitment to innovating for safety and efficiency in space exploration. 3. International collaboration and the Artemis Accords. The Artemis program is not only a national effort but also a global initiative. The Artemis Accords represent a framework for international collaboration in space exploration, promoting transparency, safety, and shared benefits. With over 50 countries participating, this cooperative approach aims to ensure that space activities are conducted sustainably and peacefully. The focus on international partnerships reflects a broader understanding of the shared challenges and opportunities in space exploration, fostering a sense of global responsibility and collective achievement. For future aspirations, Mars and beyond, the Artemis program is viewed as a critical stepping stone for future human missions to Mars. By establishing a sustainable presence on the Moon, NASA aims to gain the necessary experience and knowledge for longer duration missions to Mars. The scientific discoveries made during the Artemis missions, particularly in understanding the Moon's geology and potential resources, will inform strategies for human survival and exploration on the Red Planet. This long-term vision encapsulates the program's goal of inspiring future generations and expanding humanity's reach into the solar system. 1. Apollo Program 1961–1972. The Apollo program was a series of missions undertaken by NASA aimed at landing humans on the Moon and bringing them back safely to Earth. The most notable missions include Apollo 11, where astronauts Neil Armstrong and Buzz Aldrin became the first and second humans to walk on the lunar surface in 1969. The program achieved a total of 6 lunar landings, returning with valuable scientific data and samples that significantly advanced our understanding of the Moon and broader space science. 2. Mercury and Gemini programs 1958 to 1966. The Mercury and Gemini programs were precursors to the Apollo program, focusing on human spaceflight capabilities. The Mercury program, which included missions like Freedom 7 carrying Alan Shepard, was the first to send humans into space. The Gemini program followed, facilitating longer flights and the development of critical technologies such as spacewalks and orbital rendezvous. These missions laid the groundwork for the eventual moon landings of the Apollo program. 3. International Space Station 1998-present. The ISS is a collaborative project involving multiple countries including the United States, Russia, Japan, Europe, and Canada. It serves as a microgravity and space environment research laboratory where scientific research is conducted in astrobiology, astronomy, meteorology, and physics. The ISS represents a significant international effort in space exploration, promoting collaboration among nations and advancing technologies that will support future missions to the Moon and Mars, similar to the goals of the Artemis program. Future outlook, predictions for NASA's Artemis program. The Artemis program, initiated by NASA, aims to establish a sustainable human presence on the Moon and serve as a stepping stone for future crewed missions to Mars. The program has already made significant strides with Artemis I, II, and III, and its trajectory suggests a promising future for lunar exploration and beyond. Short-term predictions 2025 to 2030. 1. Successful crewed missions. Following the anticipated launch of Artemis II in April 2026, NASA will validate the capabilities of the Space Launch System (SLS) and Orion spacecraft in a crewed lunar flyby. This mission will pave the way for Artemis III, projected for mid-2027, which will mark humanity's return to the lunar surface since Apollo 17 in 1972, with astronauts exploring the Moon's south pole. 2. Increased international collaboration. With the Artemis Accords signed by over 50 countries, the program will likely enhance international partnerships. Countries like Canada, Japan, and various European nations are expected to contribute technology, science, and resources, leading to a more collaborative approach to lunar exploration. 3. Scientific discoveries and resource utilization. Artemis III missions will focus on scientific research, particularly regarding lunar geology and potential water ice resources. The discovery of water on the Moon will be crucial not just for sustaining human life but also for fueling future missions to Mars. 4. Development of lunar infrastructure. Following Artemis III, NASA will likely focus on establishing a lunar base camp or gateway, a space station in lunar orbit. This will facilitate long-term human presence, enabling extended missions and scientific research. 5. Commercial partnerships. NASA's collaboration with private companies such as SpaceX for the Human Landing System (HLS) will continue to grow. This trend will lead to increased commercial investments in lunar exploration, ultimately fostering a lunar economy. The development of technologies for lunar mining and transportation will emerge as key areas of focus. Midterm predictions 2030 to 2040. 1. Sustained lunar presence. By the early 2030s, NASA aims for a sustainable human presence on the Moon with regular missions planned. This will include the deployment of habitats, research facilities, and eventually the establishment of a lunar economy, including the potential for mining operations. 2. Expansion of scientific research. As more missions are conducted, the Moon will be utilized as a platform for scientific research that can't be achieved on Earth. This includes astronomy, geology, and the study of lunar regolith for understanding the solar system's history. 3. Preparation for Mars missions. The experience gained from living and working on the Moon will be critical for planning crewed missions to Mars. NASA expects to leverage lessons learned regarding life support systems, radiation exposure, and surface operations to inform Mars mission designs. For technological innovations, the Artemis program will drive innovation in space travel technologies, including advanced life support systems, habitats, and propulsion technologies. These innovations could have applications beyond space exploration, such as in telecommunications, materials science, and energy generation. 5. Public engagement in education. The Artemis program aims to inspire a new generation of explorers. Educational initiatives will likely increase promoting STEM, science, technology, engineering, and mathematics fields and fostering interest in space exploration among young people. Long-term predictions 2040 and beyond. 1. Crewed missions to Mars. If the Artemis program meets its goals, NASA aims to send the first humans to Mars in the late 2030s or early 2040s. This ambitious endeavor will mark a monumental achievement, extending human exploration beyond the Moon and into the Martian environment. 2. International space cooperation. As space exploration becomes increasingly international, future Mars missions are expected to involve partnerships with global space agencies and commercial entities. This will enhance the capacity for exploration and research, with shared resources and knowledge benefiting all parties. 3. Mars settlement efforts. Following initial crewed missions, the long-term vision includes the establishment of a sustainable human settlement on Mars. This will involve developing habitats, life support systems, and sustainable food sources, ultimately aiming for a self-sufficient colony. For astrobiological research, Mars missions will focus on the search for past and present life, understanding planetary processes, and studying Martian geology. Insights gained will enhance our understanding of life's potential beyond Earth and the conditions necessary for habitability. 5. Expansion of human presence in the solar system. With a successful lunar base and Mars missions, humanity will be poised for further exploration of the solar system, including potential missions to the asteroids, Jupiter's moons, and beyond. This could lay the groundwork for interplanetary travel and exploration. Conclusion. The Artemis program is a cornerstone of NASA's vision for the future of space exploration. By establishing a sustainable presence on the Moon, the program not only aims to unlock the Moon's secrets but also prepares humanity for the next giant leap, exploring Mars and beyond. As we look to the future, the intertwined goals of science, international cooperation, technology development, and education will drive the next era of human exploration, ensuring that the legacy of Artemis inspires generations to come.